Okay, this is your study guide for Physics 103, Physics 203 final. This follows the study guide that I put on Blackboard. For the first one, be able to measure the dimensions of an object with a vernier caliper. So I'll likely give you a cylinder, and I'll give you the caliper, and you'll have to measure the diameter. And just remember that when you're using a caliper, that you're supposed to have 3 decimal places, and that's measured in centimeters. The last decimal place is either a 0 or a 5. If you want to come by my office and try a caliper, you're welcome. Be able to calculate the average, the standard error, and the standard percent error for a given set of data. I'll provide you the equations. The equations for average is the sum of the individual data divided by the number of data points. The standard error is the square root of the sum of x minus x bar squared divided by n times n minus 1. This is all underneath the square root. So the square root of that. And then the standard percent error is the standard error over the average times 100. So say, for example, I provide you with these data points: x is equal to 4, x is equal to 1, and x is equal to 4. Those are 3 measurements. The average, x, will be the sum of those, 4 plus 1 plus 4, divided by the number of data points, which is 3. That's 9 divided by 3, which is 3. So x bar is 3. The standard error is the square root of 4 minus 3, that's the first data point, minus the average, squared, plus 1 minus 3, squared, plus 4 minus 3, squared. And then that's divided by n times n minus 1. That's equal to 1 plus 4 plus 1 divided by 6, square root of that. That's 6 over 6, square root of 1, which is 1. And then the standard percent error is the standard error, 1 divided by the average, 3 times 100. That is 33% standard percent error. Be able to interpret velocity and distance versus time graphs. We've done this quite a bit in the class. Position versus time graph, x versus t. The slope gives the velocity. This graph has a positive slope that is constant. This graph, for example, x versus t, has a positive slope. So that means it has a positive velocity, and it's increasing. So that means that it has a positive acceleration, since if it's increasing, that means that the velocity and the acceleration are in the same direction. We also did periodic motion, and you plotted the x versus t for periodic motion. So x versus t. At this point, the velocity is negative. So you have a negative velocity. At this point, the velocity is equal to 0. At this point, the velocity is equal to a positive number, and at this point it's also positive. And the velocity versus time graphs, velocity versus time, the slope gives the acceleration, and in this case you have a negative acceleration. One more thing about over here, you have a negative velocity here, or let's take this point for example. You have 0 velocity here, you have this velocity is positive. At this point you have your maximum velocity. That means that at this point you have a positive acceleration. Alright, at this point you have a negative acceleration. That particular point though is really just for the Physics 203 course, because we've been talking about that in our class. So for 203, be able to give both the velocity and the acceleration, tell the sign of the velocity and the acceleration on the simple harmonic motion plot for Physics 203. Be able to graph and interpret data when the physical relationship that governs the data. So say, for example, like we did in class, we said that the period is 2 pi square root of m over k. I would provide you with the relationship, whatever the relationship is, something along these lines, and the data, so t and m, give you particular numbers for these. And you would have to figure out what to plot in order to make a straight line and figure out what the slope is. If you plot t versus m, that is not a linear function. Alright? In fact, t is proportional not to m, but directly proportional to the square root of m. So we want to plot the period versus the square root of m, and that turns out to be a straight line. Alright? And then from that you find the slope, and then from the slope you can figure out what is, in this case, the spring constant. So I'm going to rewrite this function. T is equal to 2 pi over the square root of k times the square root of m. Now when we write our equation of a line, the equation of a line is y equals mx plus b. In this case our y-intercept is 0. Our x variable right here is the square root of m. Our y variable right here is the period. So our slope m is equal to 2 pi over square root of k. So let's say, for example, here your slope was 2, then you would just set, this should be k, then you would just set this equal to 2, and then you could solve for k. So 2's cancel, k would equal pi squared, which is approximately equal to 10. Alright, for example, I'd probably ask you to find some physical quantity that would be related in some way to the slope. Be able to measure the mass of an unknown through the measurement of torques. This could either be practical or written. Take your meter stick, determine the center of mass, and then balance it at the center of mass. So this is the center of mass. You'd hang your known mass, we'll call that mk, on this side, and then hang your unknown mass, we'll call it mu, over here. This distance we'll call r1 and this distance r2. Mass of the known mass plus the mass of the clamp times r1 is equal to the mass of the unknown mass plus the mass of the clamp times r2. It's implied here that there's also a g here, but those two cancel out. Solve this for mu, the unknown mass. Be able to measure the period of a spring. You have a mass on a spring hanging vertically. This is at its equilibrium position, that is x equal a. You extend this spring down a certain amount and you let it go. This spring will then go through oscillations. It goes up and then it comes back down, and the time for it to go up and then come back down is the period. Usually when you find the period, you measure the time for, say, 10 oscillations, and then divide that time by the number of oscillations to get the period. Be able to calculate the density of a substance. This could either be practical or written. So the density of a substance is defined as the mass over the volume. You can measure the mass on a triple beam balance. And you can measure the volume by displacement. When I say by displacement, you take a graduated cylinder, put a certain amount of water in it. Let's say that you put 10 milliliters of water in the graduated cylinder, and then you put your object in it, whatever the object is, and then you read the new volume in the graduated cylinder. So let's say this is 15 milliliters. You have displaced the difference between these two volumes. So the volume then of your object is equal to the volume of the displaced water, and that is 15 minus 10 milliliters, which is 5 milliliters, but that's equal to 5 cubic centimeters. So if your mass was 3 grams, for example, or whatever it is, divided by 5 cubic centimeters, then you would have 0.6 grams per cubic centimeter. Be able to calculate the buoyant force acting on a substance and determine how much of an object would be submerged in water. Alright, well, the buoyant force is given as the density of the fluid times the volume of the object. That is, the volume of the object, the part that is submerged, times gravity. And when it's floating, the buoyant force is equal to the weight. That is, that the density of the fluid times the volume of the submerged object times g is equal to the mass of the object times g. So let's say, for example, we have a mass equal to 1 kilogram and density equal to 500 kilograms per cubic meter. I want to know what fraction of the object is submerged. Alright, so we start with this formula over here. Rho Vg is equal to mg. It's the mass of the object, the density of the fluid, and the submerged portion of the volume. Now your gravities cancel. I'm going to put in some numbers here. I have 1,000 times the volume that is submerged, and that's equal to 1 kilogram. That's the mass. So the volume of your object that is submerged is equal to 0.001 cubic meters. Alright, but then that's the volume of the block that's submerged, not necessarily the total volume of the block. To find the volume of the object based on the density is mass over density. That is 1 kilogram over 500 kilograms per cubic meter. That's 0.002 cubic meters. So 1/2 of the object is submerged. I get that because I say 0.001 cubic meters divided by 0.002 cubic meters is equal to 1/2. This amount is submerged. This is the total volume. Half the volume is submerged. Be able to calculate the final temperature when two substances of different temperatures are brought together, assuming no changes in phase. Just like in lab, you have your shot over here at a particular temperature. That'll be hot. And then you have your water over here that's at a particular temperature. I would give you the initial temperature of the shot, the mass of the shot, and the specific heat of the shot, the initial temperature of the water, the mass of the water, and the specific heat of the water. Assuming that there is no heat transferred to the calorimeter, that is, that we don't worry about the cup or the stirrer like we do in lab, we can equate these two. We can say that the sum of Q is equal to 0, and the sum of the heats is the mass of the shot, specific heat of the shot, the temperature final minus the initial temperature of the shot, plus the mass of the water, specific heat of the water, temperature final minus the initial temperature of the water, and that's equal to 0. And then you solve this for TF like we did in class. TF, these variables TF are both the same because the shot and the water both go to the same final equilibrium temperature. Be able to calculate the period of motion for a plane traveling in a circular path when given the mass of the plane, the length of the supporting string, and the angle of the string from the vertical. So, and then also be able to draw the vector diagram. So let me do that here. Let's take an example. Let's say that, for example, the mass will be 1 kilogram. That's the mass of the plane. The length of the string will be 1 meter, and the radius of the motion will be 0.5 meters. And so here's my string. Here's my plane. This is L. This is theta. We'll call this R. And my forces, I have the force tension acting on the string, and then I have mg. I want to draw my vector diagrams, my force tension, and mg. This is my angle theta. This angle is the same as this angle. I can further simplify this. This is ft cosine of theta. This is ft sine of theta. And this is mg. Ft cosine of theta from Newton's second law is equal to mg. So So I can solve for ft. That's equal to mg over cosine theta. To find theta, that is this angle theta, I have the length L here and the R here. So it is just the inverse sine of the opposite over the hypotenuse, that is R over L, and in this case it's 30 degrees. So putting in those numbers, 1 kilogram, 9.8 cosine of 30, that's equal to 11.3 newtons. Now that gives me my tension force. From looking at the forces on the x-axis, I find that Ft sine theta, that is my centripetal force, so it's equal to mv squared over r, and then I can solve for my speed, which is the square root of Ft sine theta r over m, and that's equal to 1.7 meters per second. So that is the speed that the plane is traveling around. And then the period is the distance over that speed. So the period is 2 pi r, that's the circumference of your circle, over v. That's 2 pi times 0.5 meters over v, which is 1.7. And that gives me my period, which is 1.8 seconds. Alright. Now in addition, for 203, you should be able to calculate the frequency. The frequency is 1 over the period, in this case 0.6 hertz. And the angular frequency, which is 2 pi times the frequency, which in this case is 3.8 radians per second, or just seconds to the inverse.